Hi, this is John Sanchez, and this is week 1 of an introduction to interactive programming in Python. This video is on modular arithmetic. So I thought I'd start off by giving a definition of the modulo. The modulo takes a number, num1, and divides it by another number, num2, and the remainder is given back as the answer. A simple example would regard shirts. Imagine that there are 49 shirts in a pile. I'll draw that out right here. And these shirts are going to be used to fill closets where each closet fits 12 shirts. So the question is, how many are left in the pile when done? But you can only put shirts in closets when there are 12 shirts that can go in. You can't only take 11 or less shirts and put them in a closet. Otherwise, they stay in the pile. So let's begin. If I have one closet right here, I know that 49 is greater than 12, so I can put shirts in this closet. 49 minus 12, that's equal to 37. Now I have 37 shirts still out in the pile. I'll fill another closet. There are 12 in here, so there are 25 shirts left in the pile. Fill another closet. 25 is still greater than 12. So now I subtract 12, because there are 12 now in here. And 13 left. 13 is still greater than 12. I could fill one more closet. Now, 12 shirts in here, there are 1 left. Now, 1 is less than 12, so I can't fill another closet. This one shirt stays in the pile. So my answer to 49 modulo 12 is equal to 1. Now this modulo operator has all sorts of applications in this course, from screen wrapping or finding the ones digit, and even in this week's mini project, rock, paper, scissors, lizard, Spock. I'll get into that at the end of the video. And lastly, there are 3 main scenarios that could happen when doing modular arithmetic. Let me go into those now. The first scenario is when the first number, num1, is greater than the second number, num2. Here are some examples of this. So in the first one, 5 modulo 2, I can take 5 and put it over 2, 5 divided by 2. Then I can convert this into a mixed number and get 2.5. My answer is actually just this numerator right here. 5 modulo 2 is just 1. And if I solve this problem using the shirts method, I would get the same answer. Now for the next one, 10 modulo 6. So I have 10 over 6, and this is equal to 1 and 4/6, converting it into a mixed number. And my answer is just this 4, right? And lastly, this last one's a little bit different because the 3 goes directly into 6, but I can do 6 over 3, which is equal to 2, but really it's 2 and 0/3. So 0 is my answer. 6 modulo 3 is 0. The second scenario is probably pretty obvious, and it's when you have num1 modulo 0. And when this happens, the computer needs to divide by 0 to get the remainder. But we all know that's a big no-no in math. So we have a 0 division error that's called by CodeSkulptor. Okay. Our third and final scenario is when num1 is less than num2. So this seems complicated at first, but it's actually quite simple. So I'll show you with these examples. If I turn this into a division problem again, I get 3 over 5, or 3/5. Using the numerator rule, I can actually just take this 3 and use it as the answer. 3 modulo 5 is 3. Same thing goes for this. 65 over 2, 3, 4, 5. 65 is my answer. And for this one, I'm not going to write it out, but 57 is the answer. And the reason for this is you're saying, using the shirts again, that there are 3 shirts, and you can only take them out of the pile and put them in closets when there's 5 shirts. But you start off with less than 5 shirts, so you keep the 3 shirts in the pile. There's your answer. One thing that I forgot to mention was how negatives play into the modulo operator. I introduced this expression before with 10 modulo 6, and it went sort of like 10 over 6 equals 1 and 4/6. So 4 is the answer. 10 modulo 6 is equal to 4. But what happens if negative 10 modulo 6 is the problem? Well, what I can do is I take this second number, and from that I subtract the answer to the positive version of the expression, 4. So the answer would be 2. So again, I'm taking the second number, num2, and then I solve the modulus equation without the negative sign and subtract that from num2, getting the answer. But what happens if the first number is smaller than the second number? Well, in this case, this isn't a negative, so we know how to do that. Answer is 6. But if it's negative, I'm doing the same thing. I take the second number, which is 10, and subtract 6, which is the answer to the positive version, and my answer is 4. Now for the moment we've all been waiting for. How all this applies to rock, paper, scissors, lizard, spot, this week's mini project. So here I have a circle diagram from one of this week's lectures. At various points along the circle, there are the 5 choices in the game: rock, Spock, paper, lizard, and scissors. Each of these choices corresponds to a number. Rock is 0, Spock is 1, paper is 2, lizard is 3, and scissors is 4. Down here we have the magic rule, the magic expression. By computing this, I will get a result, and by that result I will be able to figure out who wins the game. This expression states that if I take the number of player 2's choice minus the number of player 1's choice, modulo 5, I will get an answer that will help me determine who wins the game. So let me do an example. Let's say player 2 chose scissors, so that would be 4, and player 1 chose paper, which would be 2. 4 minus 2 is 2, and 2 modulo 5 is equal to 2. Now, a cool algorithm says that if the final answer is 1 or 2, player 2 wins. But if the final answer is 3 or 4, player 1 wins. In this case it's 2, so player 2 wins. Let me do one more example. Let's say player 1 chooses Spock, which is 1, and player 2 chooses rock, which is 0. 0 minus 1 is equal to negative 1. And negative 1 modulo 5, well, when you're doing a negative with modulo, you do the positive version, so 1 modulo 5 would be 1, and 5 minus 1 is 4, so this is equal to 4. And as we know, if the answer is 3 or 4, player 1 wins. So in this case, player 1 is the winner. Thank you for watching, and I hope this helped. Bye!